So, question 5. In this question, you're required to show detailed reasoning. So this is the first of our detailed reasoning ones. The line x plus 5y equals k is a tangent to the curve x squared minus 4y equals 10. Find the value of the constant k. Once again, there are a number of ways that we can deal with this. If the line is a tangent, I think my first instinct with this would be to say if the line's a tangent and it's a quadratic curve, that means there is only one root and it's one repeated root. Of the simultaneous equations. So that's how I'm going to go with this. I think looking at this equation here, x plus 5y equals k and x squared minus 4y is 10. If I'm going to do simultaneous equations on that, then I'm going to say the first equation tells me that x is k minus 5y, and I'm going to sub that into the second equation to get k minus 5y minus 4y is equal to 10. That's squared, sorry, it was x squared. That gives me k squared minus 5ky minus another one, so minus 10 times k times y plus 25y squared minus 4y is 10. So 25y squared, what have we got then? Minus, yes, 10k plus 4, lots of y, plus k squared, take away 10, is 0. Okay, and what I just said at the start of this was that if the line is a tangent, this means that this has repeated roots. It's a quadratic in terms of y. If it has repeated roots, then b squared minus 4ac must be equal to 0. So I'm going to go with b squared minus 4ac. That is b squared minus 4 times a times c is equal to 0. Not the nicest of equations. This was minus here, wasn't it? I mean, I suppose I should do that, but we know that minus is going to turn out positive anyway. If I multiply out the bracket, then I've got 100. Is this the most efficient way of doing it? It probably is. 100k squared plus 40k plus another 40k plus 16 minus 100k squared. Oh, that's convenient. Plus, what would that be? 100 times 10, so plus 1,000 is equal to 0, I think. Then what we end up with. So the k squareds have cancelled out. We're left with 80k plus 1,016 is equal to 0. So k is minus 1,016 over 80 minus 1,016 over 80 gives me minus 127 over 10. And it's not the most satisfying of answers, but that is the correct answer. There we go. Obviously, that's not the only way of doing it, because what you could have thought is this could be a differentiation question. If that line is a tangent, that line has a gradient of minus a fifth, and I want to find where does this curve have a gradient of minus a fifth by finding dy by dx, putting dy by dx equal to minus a fifth. The coordinates must be the same at that point, and so work through the coordinates, match them up, find the coordinates where the curve has that gradient, and sub that x value into that one and find the y value so you can work out k, or sub x and y in there to work out k. So that was another way that you could have done it, and would also have given you the right answer. Is that all right? And that's maths.